Hi, my loves. I hope you all are doing great. I have missed doing math with you guys over the last week. I hope you all had a fun spring break at home. Maybe you found some math activities to do at home. Hopefully so. Today we're going to continue our unit on measurement, and we're going to work with something that we actually did a little bit of work with in third grade, so you should already know a little bit about it, which will make it a bit easier. So as I am teaching today on this video, you can have open your area and perimeter slides. They're located under the cross math section under content on the eClass page. I'm going to go through the slides with you. I'm going to model the problems that are in the slides, and then you're going to do some practice area problems on your own. All right, so our two learning targets for the week are: I can apply area formulas for rectangles in real-world math problems. So you're going to need to know the formula you use, which we learned last year, so you should already know it, to solve area word problems. Now, the cool thing is you're only going to be dealing with rectangles this week. Okay, so we're going to learn how to do rectangles really well before we move into some different shapes next week. On Friday, I'm going to be back and I'm going to be teaching you how to say I can apply perimeter formulas for solving real world problems with rectangles. So we've done that too in third grade. Hopefully you remember. I just want to be really sure you don't mix up area and perimeter, because that can be kind of a common mistake that we might make. So today we're focusing on area, and when we do math again on Friday, we will focus on perimeter. Now, on Wednesday, I found something kind of fun when I was doing today's slides. The guy who makes all of our favorite Estimation 180 website pages, I guess we'd call them, has made a scavenger hunt, a math in your home scavenger hunt that you can do while you're at home. And so I'm going to post that on Wednesday. On Wednesday, we're not going to have any new learning. We're going to try and have some kind of fun, catch up, and review things, but that'll be something to look forward to on Wednesday. Okay, so you do have an Estimation 180 today with Easter coming up this weekend. I know not all of us celebrate Easter, but I thought we could all at least enjoy a chocolate bunny, because who doesn't like chocolate bunnies? So go ahead and pause the video, do your Estimation 180. Remember to start with your estimates that are way too low, then your estimates that are way too high, and then your estimates that you think are correct. Okay, pause and come back when you're done. Okay, so to start our mini lesson today, I just want to do a little bit of review with you on what area is. We talked about area and perimeter in third grade. You should remember them, but I want to review them because it's been a while since we've talked about it. So you've got to be careful not to mix up area and perimeter. So we're going to really focus on area today so that you understand it, you remember it, you know how to find it, and then we'll do some perimeter on Friday. So you're going to need to know the formula for each one, which is how we solve for area or figure out the area. And you're going to need to know the units that we measure in. So if you switch to the next slide, it says, what is area a measure of? And if you remember back to third grade, area is a measure of the two-dimensional, the flat space in a geometric figure. So it could be any shape, but we are going to be doing, I just have this right here on my table, rectangles, okay? So the area of this rectangle is the amount of space that it takes up. If I wanted to cover it with another piece of paper that was exactly the same size, I would need to know the area so it would match up. So I've got a little model there on the slide for you, and you can see that figure, if we count up all those little squares, those are called square units. We're going to talk about that in just a second. You can see that rectangle has an area of 15 square units. It covers 15 units. Now, if you switch to the next slide, hopefully you remember this from third grade. How do we find the area of a rectangle? So last year we learned a lot about this and how we multiply the side length of one side of the rectangle by the width of the other side of the rectangle. So we multiply those together, length times width, and that gives us area. Now it's also really important that you remember that area is measured in square units, okay? So it could be square inches, square centimeters, square miles, square feet, but we do that with that little 2 kind of high up in the sky next to your unit. And you'll see that on your slide, and you'll also see it in just a minute when I model the problem behind me. So area is a measure of the space that a flat shape takes up, and we're going to be doing rectangles. Keep in mind, squares are also rectangles. Don't forget that, because you might see that as well. And they're measured in square units. So let's go to the first problem, okay? Also keep in mind that when you solve problems with area, you're going to be looking for an unknown. Your unknown might be the length of one side. It might be the width of the other side. It also might be the area. So you're going to have to take the information that you do know to figure out the one thing that you don't know. That would be the unknown. So for this problem, it says, Miss Cross is covering the floor of her children's playroom with foam squares to make the playroom safer. How many 1-foot squares of foam will I need to cover up the entire floor? Now, I know we're supposed to look for important numbers in problems. I don't see any numbers except the one that says 1-foot squares. So that's telling me that my units, my squares that I'm going to be covering the floor with, are 1 square foot. It means they're a foot on each side, right? So they're 1 foot on each side. All the sides are equal, so they are squares. So it's got a drawing, and I drew this back here for you. So even though we don't have numbers, we have some information in this picture that we're going to use to figure this out. So hopefully you notice that these units here are marked off. Those are hints for us. So I'm going to look at it. I don't see any numbers, so what am I going to do? I'm going to count. So first I'm going to count the length. 1, 2, 3, 4, 5, 6, 7. So it's 7 square units long. Now I'm going to count the width. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my length is 7 and my width is 8. And if you remember, sorry, I should have written this up here already. Area equals length times width, and one of those is always, well, mostly, going to be our unknown that we're solving for. So in this problem, we have our length, we have our width, our area is what's unknown. So I'm just going to do A for area equals 7 times 8. Hopefully we're still practicing our multiplication facts, and we know that 7 times 8 is equal to 56. So our unit was feet. And because it's area, we know that those are square feet. So I write that little 2 up high in the sky there. So using what I had, counting the sides here, I was able to figure out that my length and width are 7 and 8. I multiply them together to get 56. You're going to see problems like this on your practice today. Be sure you write this for every problem. It'll help you remember the formula. Okay, so for every problem, you're going to write area equals and whatever your length and width are. Be sure you type that into your Google Doc, because that is going to be part of your answer. Okay, next problem. Mr. Cross bought 24 feet of fencing material from Lowe's. He's trying to decide what dimensions to build a garden in his yard. What are some different rectangular figures he could choose from using all 24 feet of fencing? Determine the area of these rectangular figures and explain, don't forget to explain, which figure you think he could use. So in this case, we actually have 2 unknowns. We know that area equals length times width, and we know that our area is 24 square feet. I don't know my length or my width. So now I have to use what I know about multiplication in order to figure out what this area of the garden could be. So I need to think about what numbers can I multiply together to get 24. So this takes me back to factors, right? I'm thinking of factor pairs. And the first one I think of is 1 times 24. That would equal 24. So his garden could be 1 foot wide by 24 feet long. It's possible. What else equals 24 when we multiply together? What about 2 times 12? Okay, so his garden could be 2 times 12. Now, are there more factors for 24? Let's see. What about 3 times 8? That would work. Now, is 5 going to be a factor of 24? I don't think so, because all of the multiples of 5 either end in a 5 or a 0, and this does not. But what about 4? 4 times 6. Good. So, picture each of these as a garden. So if we had 4 times 24, I'm sorry, 1 times 24 would be really long and really narrow. You think that'd be good for a garden? I don't know. 2 times 12 would be a little bit wider and a little bit shorter. 3 times 8, a little bit longer, a little bit narrower. And then 4 times 6 would be closer to being a square. It's not quite, but closer. So I want you to think about which one of those make the most sense. Which do you think would be the best garden dimensions for a garden that has an area of 24 square feet? And you can type this answer into your Google Doc under math. I'm going to let you read the summary on your own today because I have a fabulous joke in there for you. And then you're going to go to Cross Math, either download the practice sheet or just open it on your screen and type the answers into your Google Doc under math for the week. And let me know if you have any questions. I miss you guys so much. I'll see you soon. Bye.